This video, we're going to talk about 1.1 Objective 7, where we interpret the slope of a secant line. A secant line is going to be a line that gives us the average rate of change between 2 points on a curve. So let's go ahead and let's look at this. We've only got a couple examples. A function and an interval of its independent variable are given. The endpoints of the interval are associated with the points P and Q on the graph of the function. Answer parts A and B. So after t seconds, an object dropped from rest falls a distance of d equals 16 t squared, where d is measured in feet. T is between 2 and 5, so there's my A and B for my interval right there. That's what they're talking about. So f of A, we need to find. F of 2 is going to be 16 times 4 is 64. F of B is going to be 16 times 25 is going to be 400. So sketch a graph of the function of the secant line through P and Q. Let's go ahead and find the slope. So the slope is going to be f of 5 minus f of 2 over 5 minus 2 is going to be 400 minus 64 over 3 is going to be 336 over 3 is 112 for my slope. And we would have to use point slope form to pick a point. I'm going to pick the smaller numbers here. So y minus 64 equals 112 times x minus 2. It needs to go through both of those points there, though, 264 and 5 400. So 2, 5. It could be B. It is B because C and D have parabolas that open down, and that's not right. And A doesn't have the points in the correct location. So it's B. So it's kind of hard to see that line, but it's right there. The slope of the secant line is 112. We just found it, which means the object falls at an average rate of 112 feet per second. Over the interval of time is 2 seconds to 5 seconds. So there we go. A function and an interval of its independent variable are given. The endpoints of the interval are associated with the points P and Q on the graph of the function. Answer parts A and B. So the volume of a gas in cubic centimeters, that's going to be important that our unit is going to be cubic centimeters here, is given by volume equals 8 over P, where P is the pressure in atmospheres. That's going to be important here. And P is between 0.5 or 1/2 and 4. So sketch the graph of the function and the secant line. Well, so 1/2 matches up with 8 divided by 1/2 is 16. And 4 matches up with 8 divided by 4 is 2. So I should have 1/2 16, 4, 2. This should be a decreasing function. 1/2 16, 4, 2. That looks like B to me. And the slope is going to be, let's see, 16 minus 2 over 4 minus 0.5. I'll call that 1/2. It's going to be 14 over 8 halves minus 1/2 is 7 halves. So this is 28 over 7 is 4. And this was the other way around. 2 minus 16 is negative here, negative, negative. It's decreasing. The slope is -4. This means the volume changes at a rate of -4, and then this is going to be cubic centimeters per atmosphere. So the volume changes cubic centimeters per atmosphere. All right, that's it for this video. We'll come back next time and start talking about our topics from section 1.2. See you for the next video.